Given that the function f and gx are as follow, so the function of fx is a modulus x, function of gx is a linear function, determine the domain and range for these two. So domain of fx, domain we calculate for SLR, surd, log, and rational. Range we find for causal, quadratic, absolute, surd, rational, and exponential. So for absolute function, in the domain, it is not a special case, so no need to calculate, just negative infinity to infinity. Meanwhile, for the range, so absolute is a special case in range. We need to close out the absolute, see the value out here, we can see it's 0. And the absolute that I close here and I refer here is having a positive coefficient, so it is positive infinity. Then this is the minimum value you should have. So it will be included for this 0. Then I move on to linear function. Domain for linear function is not special case, that is referred for the log. So it will be negative infinity to infinity. Range of the function g linear also not a special case, so negative infinity to infinity. And then we need to find out question B, what is our composite f gx. So we substitute the gx here, x minus 1, and x minus 1 substitute in the function f here, x is replaced by x minus 1, so modulus x minus 1. So we have a modulus function. So to draw this modulus function, again we need to calculate its domain and range so that we can know where is the graph located. So domain for f gx absolute is negative infinity to infinity. Range for this modulus function, we see 0 up there. Then this is positive, so 0 to infinity, which means that absolute function having the range 0 to infinity is going up. So domain is left and right, range will be going up or down. So to infinity means going up. Going up, absolute function shape is V shape, so going up like this. So what is your minimum value here? Y coordinate is 0, as you can see here. X coordinate you have to read back inside the modulus, which is 1. So x minus 1 means x equals to 1. So this is your minimum coordinate. Now we're going to sketch this graph. So set out the x-axis and y-axis, and we know minimum point as here 1, 0, and we go for the absolute V shape. As you can see, when it intersect with y-axis, you need to calculate y intersect happen when x equals to 0. So when x equals to 0 is modulus negative 1, so it is equals to 1. So we label. At the end of the sketching is labeling. So f gx is modulus of x minus 1. Then for question C, is it this f gx, this composite function is a one-to-one function? Give your reason. So as we see, we already draw out this modulus graph. Is it a one-to-one function? We can say from the graph. We can use graphical method. We perform our horizontal line test. Show up it intersect 2 points from the graph. Using horizontal line test, it intersects at 2 points. So therefore, this come out a conclusion that saying f gx is not a one-to-one function. So with the reason is we are using horizontal line test. So label horizontal line test, testing up intersect 2 points. And then we continue for the question D. They say state the possible domain for this function to have inverse. If you're taking the whole piece of the function, it is not possible to be inverse because it's not one-to-one. When it's not one-to-one means it cannot have it inverse. So only one-to-one function having inverse. Therefore, it will depends on you whether you want to select half of the graph only. So if you select half of the graph, if you're taking to the left hand side, it will be negative infinity to 1, the domain, the new domain to have the inverse function. Or we can take the right hand side, which is 1 to infinity to have 1 to 1 function, so that this part can be inverse. If you want to take whole domain negative infinity to infinity, cannot be. It is not 1 to 1. So here we have two type of the answer, two solutions here. You just only choose one as a answer. So I go for the answer number 1 first. Option. Option of answer number 1. Let's say I taking the right hand side. So I will cut this graph to be half, which is start from the domain of fgx that I will going to select is 1 to infinity, so that I have this half. It is a 1 to 1 function and it can be inverse. So which it has inverse. Then I need to continue to answer this. Question is sketch the inverse graph. So draw back the graph. Y-axis, x-axis, and I select the new part will be 1 to 0 here. So 1 to 0 here, which is our fgx. Then if I want to get my inverse graph, I need to do refraction. My refraction axis will be y equals to x. When you're drawing this refraction axis and this modulus line, make sure your gradient they are same. Means they will having parallel line, because you can see y equals to x, gradient is 1. When I'm doing this modulus graph x minus 1, the gradient also 1. So these two lines should be having the pattern of parallel to each other. Then only we inverse it. When we inverse it, the graph also come up parallelly for this fg inverse. So this is how we answer for the first option if you're choosing the right part from the modulus. So we do have another option of the answer. Let's say we also can choose for the left hand side. So answer number 2. So the domain of fgx I'm going to select is the left hand side. So the left hand side will be negative infinity up to 1 only, which it will have inverse. Then we draw it. Question E. So drawing f inverse function, you will not exclude from refraction. So when you're drawing inverse function, it must come with refraction axis. Alright, so we come to the left hand side part that you want to take here. So 1 to infinity, 1 to 0 here, 1 up to 0 here. So this is the intercept that we found just now, which is 1. Then I label this is fgx, the original function that have been taking one part only to be inverse. And don't forget label. And now we can doing the refract. So you can notice that this x and this x, if you see this part, this is positive x, this will be negative x. So we were having 90 degrees. So when you're doing the refraction, so here we come, this is the refraction. Maybe I draw with this, it will be more clear. So this this side of 1. When I reflect, it will get to here. And this side, it will prolong it to down here. So this is FG inverse. So if you're doing FG inverse, write it properly, it will be FG inverse. It means the composite inverse. If I write FG inverse, it means G inverse composite with F. This is different. This is the whole composite function inverse. This is just G inverse. So after you've done this, make sure you label. You have your y-axis, x-axis, you have your function, you have your reflection axis, and label with the coordinate. So here I show you two kind of answer we can accept. So if you in your exam, you just select one part of it. Don't do both answer together. If you do both answer together, we assume you want to take both part of the question, both part overall of the graph already. Alright?